All right, part 4. This is gonna be the last part. At least I think it's gonna be the last part. I'm gonna continue on from it. Solving quadratics with imaginary solutions using the quadratic formula. So before we solve some of these, we have to go over quickly what is going to be different. And what is different is you're getting a discriminant, right? So imagine you have negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, right? You got the quadratic formula. Imagine this is the b squared minus 4ac, and you've gotten a negative discriminant. Well, if you try and do the square root of a negative number on a calculator, it's going to say error or syntax error, or it's not going to work because this is an imaginary number, right? So what we're going to do is the same exact process of simplifying simplifying radicals that I believe I discussed in part two. Part 2, I think it's part 2. I mean, we did an example in part 3 of simplifying a radical. So make sure to watch those videos first before you watch part 4. It's the same process. It's the same exact process, except for this negative. You factor out, you divide out a -1 because -1 times 16 is -16, and you separate this out into 2 different square roots. And the square root of -1 is I. And honestly, I skip all of this. I skip this whole thing. I skip that whole thing. And I skip that whole thing. And if I see a negative, I just put an I on the outside. All right. If you see a negative, you can just do the square root of 16 I on the outside, and you put it at the end. All right, really important that you put the number that has I, especially if you're getting like 2 plus or minus the square root of 3i. This needs to be at the very back, and this number does not go in front of that number, even if it's a whole number. If you get like 3 plus or minus 2i, first off, that does not make 5i, right? That does not make 5i. This is imaginary. This is real. You cannot combine imaginary numbers and real numbers. Can't combine them, all right? Cannot combine those together, all right? I want to be very clear on that. You cannot add a real number to an imaginary number. There's a whole thing that we start talking about in pre-algebra about combining like terms. A real number is nothing like an imaginary number. You cannot combine those. All right, I think I made my point. So let's solve some of these. And I posted down here, right? Literally the same process. You just get an I on the outside, making it an imaginary number. Well, it doesn't make it an imaginary number. It is already an imaginary number. Anyways, we're going to continue from where we were at in part 3, and we're going to solve some stuff in the same process, but you're going to see one difference, and that is that there's going to be a little tiny I somewhere in the problem. All right, so my A value is equal to 1 because it's invisible. So B is 2, 2, A value is 1, 1, C value is 10. So I get -2. 2 squared is 4. -4 times 1 times 10 is -40. -2. I'm going to get -36 here. So what do I know? I know that I have 2 imaginary solutions. Right? They are imaginary because the discriminant is negative. If the discriminant is negative, going all the way back to the very first, somewhere buried in here, one from part 3 video, from the video part 3, if the discriminant is negative, this parabola does not cross the x-axis, and there is no real solution. There's two imaginary solutions, all right? So the discriminant's negative. Oh, I'm forgetting something. What's 2 times 1? 2, 2, 2. Okay, I'm going to drop the -2. The square root of -36 is, I am going to say, how many steps am I trying to do this in? Well, I'm just going to separate this out into the square root of 36. And I'm going to put I at the end. Right? The negative became an I. I factored out a -1, and that became I. The square root of -1 is I. So if you have the square root of a negative number, you take the negative, you factor out the negative, you take the square root of -1, and it becomes an I. Not in front, you put it at the end. All right, so what is the square root of 36? The square root of 36 is 6. All right, and I've separated this out into two different parts, so I get over 2 over 2. What is -2 divided by 2? That would be 1. I think when I was making this, I had this going to be one extra step than it is. What is 6 divided by 2? 3. I. Now, like I was just saying, can we combine these? No, we cannot. So I obviously thought there was going to be more, or when I did this the first time, I did it with an extra step. X equals 1 plus minus 3i. That is the answer. Now, it is okay if you do x equals 1 plus 3i, comma, 1 minus 3i. All right. And you might see this. These are called complex numbers. Why are they called complex numbers? Well, we got a real number combined with a imaginary number. Seems pretty complex to me. I honestly don't know if that's why they call it a complex number, but it's complex. You got imaginary stuff being combined with real stuff. Complex number. And what those are is a plus bi. So the imaginary part always comes after the real part. All right. Real part, imaginary part. Real part, imaginary part. All right. Let's do another one. All right. We got 16, -48, 37. Okay. Big numbers. Throwing in some big numbers. We got -48. -48. A is 16, 16. And C is 37. So calculator. What do we got? We got 48 times 48. 48 times 48. 2,000. So well, double negative is positive. So I got 48 out here. We got 2,304 minus 16. So 4 times 16 times 37. 2,368. So I'm gonna drop the 48. Minus 2, 3, no, minus 2304, 2304. We get -64. So again, the discriminant is negative. So what do we know? Well, for one, this video is all about imaginary numbers. So 2 imaginary numbers, 2 imaginary solutions. So what does that mean? That means that we're going to have two unreal, unequal solutions. All right. 2 imaginary solutions means you're going to get 2 unreal, unequal solutions. So, oh, God, I always forget. And so do my students. And it's really easy to forget about this bottom piece. Don't forget it. If you're messing up on a quadratic formula problem, go back and make sure that you have the denominator still there. Common mistake. You just get caught up in it. All right. So again, I'm going to factor out a square root of -1 out of that, and I'm just going to get an I on the end. So I get the square root of 64. I. Now it's really important that I is on the outside of the square root, right? It is not the square root of 64I. It is the square root of 64 times I, right? This I is on the outside. And we still got 48 out here. All right, we're going to separate this out. 32. Oh, gosh. Whew. Long day. We got 48 here. We're going to get, I'm going to do the step that I didn't do last time. So this step is just to separate it out. Then we're going to get 48, 32, 8, because the square root of 64 is 8, so we get 8I over 32. We can simplify these, and I'm pretty sure this one I can divide out a 16. So this would be x equals 3/2 plus or minus. What can I divide out of this? I can divide an 8 out of this, and I just get I over 4. Right now, that might not be the answer your teacher's looking for. Another one could be, instead of separating this out, you can change this to be 48 plus or minus 8I over 32. And then from here, simplify. So what goes into 8, 32, and 48? Well, 8 also goes into 48 6 times. So we can divide an 8 out of everything, and we get 6 plus or minus I over 4. So both of these I would say are acceptable answers in my opinion. This one is more in the realm of A plus or minus BI, because it's been separated out into this is A and this is BI. Whereas this has not been separated into its two separate parts, right? Because we have this number here is a real number, right? This is real. And this over here is imaginary. So that's the difference between this and this is not separated out into A plus or minus BI. So I would say this is more preferable if you can get it all the way separated out. Good job to you though if you get here. That's still pretty darn good. Now my students are on a computer program, so they better answer how the computer wants it answered. Moving on. This is the last example. All right. So what do we got? We have B is 48. 48. A value 16. C value 37. We get negative 48 here. I feel like I just did 48 times 48. Yep, we did. You get 2,304, and then negative 4 times 16 times 37. That was not right. Negative 4 times 16 times 37. All right, and we're going to get minus 2,368. Why does this look like the same exact is this literally? The last one was negative. So I don't know. We're going to roll with it. I feel like I'm repeating a problem. I 100% feel like I'm repeating a problem. Whatever. Okay, so 4 times 16 times 37. I'm going to double check. 4 times 16 times 37. All right, well, we're going to get 32 down here. The only difference is this number is not negative between this problem and the last problem. I should have chose better. I made this too late at night. All right, negative 48. And inside, we're going to get negative 64 again. I don't know what problem I was thinking this was going to end up as in any way, because we're getting the same thing again. Yeah, I don't know. I don't know what I was thinking. Well, I guess I'll just show the long way, right? You can factor out a -1 there, and you're left with 64 over here. Drop 32, drop 32, negative 48. Then you're going to get negative 48 here. This is not going to be, you're not going to put I in front. So actually what you would have over here is still 64. And at the end, you would put I. And we're going to separate this out into 32 and 32. And then there's not a square root anymore. So I picked the wrong problem. I don't know what's going on. I chose incorrectly. So separated out into, right? We separated this out into, we got the real, we got the imaginary. So negative 48, 32, you can again factor out 16. So you get negative 3/2 plus or minus. So this would be 8I over 32 still. I'm going to simplify it again. Negative 3/2 plus or minus I over 4. So that would be what x equals. So again, you have your real part, you have your imaginary part, right? This is A plus or minus BI. And again, I filled this in a couple times, right? This is 2 imaginary solutions. I'm making my students fill that in over and over again so that they get it ingrained into their brain that when the determinant is negative, you have 2 imaginary solutions. I think there's some science study that you have to write something 7 times for you to really remember it. So at least that's 4 times you've had to write it, 3 times. I briefly want to show, if I went back and off to the side, like let's say you had, I don't know, 50 plus or minus the square root of 24I, right? So you factored, it was up here, this was 50 plus or minus the square root of negative 24. You factored out the I, all right? You factored out the I. Let's say this is all over 15. No, I don't want 15. All over 2. So let's say this is all over 2. So you're just continue on. This is a totally fake problem. I do not know what quadratic equation this goes to. So you get 50 plus or minus what? The square root of 24. If you were to do the long process, this would simplify to be 2 square roots of 4 times 6, 6I over 2. You would separate that out, right? You would separate this. So what's 50 divided by 2? 25 plus or minus 2 divided by 2 is 1, and you just get the square root of 6I. So what I was trying to do with this problem is show you an example of an imaginary or a complex solution where you still have a radical, is what I was attempting to do. All right. So you might still have a radical in your answer, but it's important that you separate it into the real and the imaginary parts, right? We want it to be A plus BI. Wow, did I butcher that last problem? Okay, I really hope all of that made sense. If not, let me know and I will do a better job of making a new problem for that. If you're my students, you can literally rip off that back page because it's identical to example 7, right? This is example 8. Rip off example 8. I don't know. That was my bad. To all of you, whoever's watching, I hope you found that helpful. So thank you for sticking with the video.